So today we are going to look at the introduction to software engineering. First of all, I will apologize for starting late because today is when I have been also enrolled to be the instructor. I have been talking to the e-learning admin and he was like the system had some challenges. Now that's why when you go to the platform you'll see that there is no content, but I have all the content, so I'm going to upload, and even the course outline is not there. Now before you go any further, let's begin with the word of prayer. Our dear kind and loving Father, I thank you for this wonderful time you've given us as we're going to study. May you help us understand everything. In Jesus' name we pray. Now, just like in other course units, we are going to have a few physical classes. This course called Software Engineering is also very wide, and you are going to find out that much of what we are going to be studying when we are discussing in class is theoretical. You won't be doing practicals like in programming courses where you are coding, where you are typing something and running programs. This is not the case with software engineering, but rather we are looking at a very big process that involves several steps, methods and theories. But now the ideas and the concepts that we discuss are applicable practically. When you study other course units like database and then system analysis and design, then you study programming courses. This software engineering course, all the concepts that we study from here will help us when we are combining knowledge from other course units to come up with a software product. So what we are discussing here is very important, and the course outline will show you that at a certain point you will have to do some practical coursework whereby you will be required to get any organization, you collect the requirements, from them you come up with the design of the product that you want to develop for them, and then you present the design in terms of diagrams. So that's the practical bit, but otherwise whatever we shall be discussing here is more of theories that are applicable in the software world. So I will be recording several videos to explain, but not everything. Mainly if I get feedback from students, then we can organize an interactive class and we discuss, or I can still create a video that explains where the challenges are. Now we are going to first understand this terminology, software engineering. The word is the terminology is a combination of two words, software and then engineering. So we are going to first understand basically what each word means. For example, what is software?
Software is a set of, you can call them a set of instructions or programs that come together to accomplish a specific task.
Okay. So you have a set of instructions or combination of programs, and these instructions are executed by the computer. So they tell the computer what to do, and now the computer will do specific tasks or certain tasks depending on the instructions given to it. So that is software. What about engineering? Because this is an English word. What do you think engineering means?
I think engineering is the art of engineering. Okay, I can explain it like when you're given a specific task, coming up with solutions and the way you can accomplish a given task that is given to you. I can call it maybe like something like engineering is the way you can find solutions to something, to a problem.
Thank you. Now the word engineering before I explain it. There are several words that are related to it, and a combination of them can further help us to know. To engineer can mean to manufacture, to create something, to come up with a product. In other words, to develop or to build something, that is to engineer. And since it is a process, not just a single activity, it involves steps, several methods and theories that are applicable. Mostly in software engineering, we call them models that you can follow to choose. It involves all the processes, the initial stages like planning. If you're going to come up with any product, you have to plan for it. Then you can come up with its design. It can be a blueprint. Then you can do the implementation. That's when you do the real building. And even after developing the product, when it is put to use, still you have to ensure that it keeps on working as expected. And that is maintenance. You have to do the follow-up. And you may also add other modules that are required or some other functionalities. So those are the updates. So that process is engineering, and that's what engineering basically means. Now we combine the two and we come up with software engineering. So this can mean software development, software manufacturing, creating software, but not as a single activity, but rather a process that combines several activities. So this process will never end, because if the user is using your product, as long as it exists, you have to ensure that the product, first of all, does what is required every time, and then user changes will keep on coming, new changes, new functionalities. So as a software engineer, you'll need to do the updates and still maintain the software. So that's software engineering in brief. Now this terminology, software engineering, is a bit foreign in the ICT world. In most cases, when you graduate or when you tell people that I'm an engineer, what do you think comes into their mind? What do they think about you? If you tell them I'm an engineer, what do you think they think about you?
Okay, in most cases, if you just say engineer, they imagine you're doing a lot of physical hard labor, coming up with maybe like mechanical, something like that, civil. That is what they consider mostly engineering, mostly the physical world, not the software.
Good. So that's what happens in the real world. So people know an engineer maybe is a mechanical engineer. You do repair, maintenance for cars, computers, you are an engineer. Even these people who do the construction, the physical work, even if a person is only putting up 2 rooms, but if that person is the overseer of the site, he calls himself an engineer. Then construction of roads, railways, and so on. So that's what people think about engineering. But now in this field of ICT, we also borrowed that term because its meaning is applicable to software. But for us, we are not like those other engineers. For us, we are engineers of the software. We create a product which is not tangible, a product which you, even the person who has created, you have a limitation to explain how it really works and interacts with the computers. But you have created using several languages, using several platforms, and it is working. But you cannot touch it with your own hands that this is the product. So, but we use the computer to create that product. So we are doing the engineering. Now, having known that, this topic is basically looking at the introduction of software engineering. So we want to see how we can develop the software in a professional way, what is involved. Then, what are the software engineering ethics that a person should possess when you are creating software? And then we have some case studies of some software projects, of which I won't go into the explanation of them. You can read for guidance, but the other 2 components are our main point of focus for this lecture. Now, we have very many software engineering books, but this one called Software Engineering by Ian Somerville is the best one according to me. I've checked several of them, but this one is easy to understand and has enough information. Software Engineering by Ian Somerville. I will still upload it, the PDF format, the whole of it, on our platform. And these slides that we have are also created from that content mainly. Okay. Now, software engineering in this modern era of technology is everywhere in all the countries, and economies are dependent on software in terms of security, business, manufacturing. Everything now is dependent on software systems. So many countries will spend a lot of money from their gross national product on software products. So that's why software engineers are very, very important in the modern world. And you will find out, if you didn't know, that the cost of software is even more expensive than that of hardware. Only that for us in Africa, we do software pirating in most cases. You just get a copy of the software from a friend free of charge. You can also distribute it to any person. Yet, software which is not open source, that's not allowed. Software like Windows, like Microsoft Office, you have to pay for it, a huge amount of money. But for us, we pirate it. It's like stealing. You get it free of charge and use it because the laws of our country, the copyright laws, are not effective. So that has resulted to that. But software is cost effective. So in software, we basically have two types of products: the generic and the customized. So as the name indicates, when you talk about generic, it comes from the word geno, meaning it is created for every person. There are many systems or software products that are created without consulting first the user. The person just sits down, thinks of an idea, creates an application to solve a challenge, but that product may be suitable for any person anywhere. Now, for example, a person who created WhatsApp or Facebook, it was his own idea. We were not consulted with the end users, but it's a product which is general. Every person can use it. You can also look at schools. Maybe if you're a teacher or you've been in the education system, you have been in several schools, you do your own analysis and you create a school management system which can be used in different schools when you have not designed it for a particular school or institute. But maybe all secondary schools in a particular country like Uganda can use it. So that is a generic product, generic software product. But now the other type of software product is called the customized product. Customized meaning it is suitable for a specific customer to meet their own needs. For example, you may develop, let me use the same example of the school management system. You reach a certain school whose processes are a bit different. The way they do things, maybe their curriculum is not that of a local curriculum. Like we have some international schools whose curriculum is different. Even the examinations, the way they do things are a bit different. So if you just come with this generic product and you give them, it won't suit their needs. It may not work for them. So you need to sit down, talk to them, do the analysis of what they want, and come up with a product that does exactly. So you are targeting on a specific customer. So that's what we call a customized software product. So that's the difference between the two. Now we have what we call product specification. The word specification comes from the word specify. To specify means when you have very many things, now narrow down and come up with exact features that you want. That is specification. So this specification is made for whichever type of product, whether generic products, whether customized. The software engineer will always do the specification. So you may think of ideas, you write down what you think the product will do, then you go through each analyzing, you find out that some of what you had wrote is not applicable or is outdated, or it may be applicable but you don't have the capability to come up with a product that does it. So you narrow down and remove some requirements and you remain with what you will be able to work with. So that is software specification, whether it is customized, whether it is generic. Then for customized, when you go to gather products, you talk to them and they give you, requirements. They give you what they expect the system to do. As you are specifying, you have to talk to them still and you agree. You may even do the specification depending on their budget. Much as they may need something which does whatever they want, but due to the budget, you can leave out some and do what suits their budget. And maybe after some time, you add the other functionalities with time when they get the money. So all that is specifying what the product is doing. So that's what we mean by product or software specification. So here we have some frequently asked questions about software. What is software? What are the attributes of good software, and so on? And the answers are given. I'm not going to go through them. You can get time and go through them. Now let's talk about the essential attributes of a good software. What do you think the word attribute means?
Attributes, what it should have. It's
characteristics.
Yeah, characteristics.
Good. So when you are coming up with a software, what can a person look for to determine or to know if this software product is really good or not? So what are the features, what are the characteristics of a good software? That's what we are talking about. So you have maintainability, coming from the word maintain. So software that you develop should be able to meet the changing needs. That's what we call evolving. You know, when you are coding, you should provide the means for evolving of the product. Now, the software that you develop, for example, when you look at Windows, the Windows that was developed in 98 is very different from Windows 10, because with time, as they interact with the users, they get to know that there are some other requirements, so they keep on changing features. Now, if these people had created their product in such a way that you cannot add changes, then they would be in a fix. But they ensure that their software can be able to evolve to meet the changing needs of the customer. So in that way, the software is maintainable. So this attribute is very, very important. And it is inevitable. You cannot create any product which doesn't evolve, because the world we live in, if you are to face reality, user requirements will keep on changing. Every time you create a product, at times you have not even finished what they want, they will tell you a new feature that they want you to add. So you should create a software that can meet such changes. So if a software can meet that maintainability feature, then it is a good software. So that's one characteristic. Then we have dependability and security. If you have any question or additional comment, feel free to come in. There's no problem. Dependability and security. What do we mean by software being dependable? So here we are looking at things like reliability. When people use it, does it give them the required results? Can they rely on your software product to make decisions? That is reliability. For example, if it is a sales management system, is it giving them accurate results in terms of profits, losses, and everything, so that they can get to know that this product A and B have fewer customers, so let's produce less of them and invest more on the other side. So such judgments come as a result of your software being dependent. Otherwise, if you give them wrong results, they will base on them and make wrong decisions. And if they realize it, you can even be sued. So it is very sensitive. So that is reliability, part of dependability. Then you have security and safety. The software that you develop should be secure. If it has different accounts, then you should provide means of logins through passwords and so on. And it should be safe, both physically and the product itself. Meaning, even where, for example, if the organization has a server, where the server computer is located, you have to make sure that the place is secure. Even the computer itself should be a good computer that we are using, because for any case, if you lose the information and you are the developer, you are liable even if you are not because why did you put your product on the computer that you saw does not meet the recommendations for your product? So all that is very, very important when you are coming up with a software product. And you should ensure that your software does not cause any physical damage to the users. Maybe in case the system has failed, it shouldn't lead to maybe crashing even the computer or the operating system. So it should be something easy to fix and to limit the damage in case of any accident that has occurred when it is being used. Then you have efficiency. When you talk about efficiency, first of all, we look at the response time that your product takes. You've ever interacted with the systems and you click on something, then you get a notification, maybe loading, and you spend some minutes waiting for the page to load or some action to happen. So that such a system is not efficient. That's in terms of time, response time. Then even the processing, you should create a system in such a way that it doesn't waste resources of the user. Storage, why should you create a product which takes or consumes a lot of space, yet there is another way to limit that? Or a product that will consume a lot of the processing power. So if you come up with a product that uses less processing power and takes less storage space and that responds in time, then that product is said to be efficient. Then you have acceptability. Now when you create a software product, it's very easy. I've seen it. It's very easy to come up with a product that users can refuse. And in most cases, that comes as a result of working alone. When you think for the users, you are likely to come up with a product that doesn't suit their needs. But if you work with them, for whatever milestone you reach, you show them, you deliver, and they give you feedback, you come up with a final product that is acceptable. So any good software should be acceptable. If it is not acceptable, then you may design a software which is intended for another user, not those ones that you had initially. So you should also take care when you are developing software applications. So those are the characteristics of a good software product. The guy is here. Okay. Okay.
Now I wanted to ask about maintainability. Are we looking at only the user side, or even when it comes to the software developer side? Is it like two-way? Because I could explain maintainability as far as maybe the code is concerned on the software developer side, saying it should be able to scale things of that sort. I think you get what I'm.
You are talking about maintainability.
Yes, maintainability. Are we only looking at the users, or we are also looking at the code side, the developer side, whereby it's easy for other developers to come on board. It is easy to scale the application, things of that sort.
Okay. Thank you. Now, that's a good question. All these characteristics, first of all, it is you, the developer, to enforce them. You are supposed to come up with a software which is maintainable, which is dependable and secure, which is efficient, and which is acceptable. But the reason as to why we are talking more about the users is because you are the one to enforce these attributes such that when you take them out to the user, they find the product good. When it is, if they have any change, it can meet their needs, you can add them. So now that means you, the developer, as you are developing, you should also use the coding or the implementation techniques that provide for these attributes. So if you decide to use a technique whereby you develop something once and there's no way of adding anything, then you can't maintain it. So now it is both sides, but we are looking at more of the user side, because for you to have these, you must use the methods and the techniques that provide for them. And what you have talked about is very, very critical and very important, because you are going to develop software that is going to be used by very many people. It's going to be used by very many people over a certain period of time. So if your product is not easy and very complex, it's only you who can understand it. If you die, for example, now, and your clients need more modules, there are several changes that they need to be added. Even if the source code is available, it may become a problem. So as you are developing, we have what we call good programming practices, like the codes, you put some comments to explain and so on, so that any person who lands on your source code and knows the language can easily start from there and add the changes. So all those are still part of the attributes of a good software. And these attributes that we have here, it doesn't mean that they are the final ones. Yeah, it doesn't mean, because people who write these textbooks are also human beings. Through their experience and their research, they come up with what they give you. But what you have talked about is also very, very important. My friend, you are welcome. I think this is my first time to meet you.
Yeah, it's my first time. I always know, but I don't find it. I'm honest.
But you come and you don't communicate to any, you don't call.
But I don't.
Okay. What's your name?
I'm called Innocent.
You are Innocent. You're the one who called me.
I sent you a message.
Okay, thank you. So you found us when you have already started, but we can continue. We are looking at the essential attributes of a good software, and even the author still says essential. That means these are the main important attributes. So there can be other attributes that we can add. Now, he also tries to come up with the software engineering definition. Software engineering, if you've understood it the way I've explained it, you can also come up with your own definition. First of all, you should know that software engineering is not a one-time activity, but it is a process which will involve all the stages, from the initial stages where you are collecting requirements, talking to the customer, and up to when the customer is using the product. Still the process will continue, and it will never stop unless the customer is no longer using your product, or maybe even if you die, because if you have a team, still the process continues. So this process doesn't end unless the customer resorts to leave your product alone. So that is software engineering, but he's trying to tell us that software engineering is an engineering discipline that is concerned with all aspects of software production, from the early stages of system specification through to maintaining the system after it has gone into use. So that is software engineering. And in the definition, we get out some terminologies and try to throw more light on them. Engineering discipline, because we are saying software engineering is an engineering discipline. This means we have certain theories, certain methods. We normally use models in software that we use to solve problems. And as we are doing that, we should also look at the finances of the organization, their budget. And then we choose the appropriate methods to use. Now, just like other engineering fields, like construction, we have several methods that you can use to come up with a building. Have you ever seen the builders, if maybe they are like 4, you find 4 of them, 1 on each corner. I don't know why they normally like starting with corners. They build the corners, then after time they now start filling those sides of the building. So that is a method. But I've also ever seen those who are building course by course as they rotate up to when the building goes up. And still, they do it differently. So they have several methods that they use when they come up with their product. Now, even in software, we have several ways of coming up with a product, depending on the budget, depending on how quick the product is needed. So you have several models that we shall look at, like waterfall, agile, prototyping, spiral, and so on. So you choose a certain model depending on the nature of the product that you want to come up with. Then, this terminology, when we say that this discipline is concerned with all aspects of software production, what do we mean? That all aspects involves not just one technical process that you are developing. You know, in most cases, when people hear software engineering, they run into coding, implementation, the development part. But we are saying, when we say all aspects of software production, that's just a step, an activity in what you are doing. So this also involves project management. If it is a big product, you may need a team of developers, a team of testers, a team of analysts, and so on. And then you manage the project. So all that is part of software engineering. Then there are certain development tools that you should look for. What platform are you going to use? What software are you going to use? What programming languages? If you are designing, which notations are you going to use? So all those are tools that we use when you are coming up with a product. Then you also choose the model. So all that is part of software engineering. And even when the product is finished, you continue to interact with the user to see if the software is continues to do what they want. So that is software engineering. Then you have the importance of software engineering. Now, many economies nowadays will rely on software systems. I think there isn't any single country which doesn't rely on software systems, because each country will have some systems, government systems, where they keep their secrets. They have banks which work with software systems. Security and the military will always use systems. Even the helicopters, the airplanes, and so on, they use software. The pilots and those who guide them are using software. So software is very, very important in any economy because they will always rely on them. So that's one importance of software engineering. Then another, and not only economies or the society in general, but individuals. You want to play music, you use software. You use an application like VLC, like Windows Media Player, like Virtual DJ, and so on. So even individuals will use these products. You want to type something, then you look for a typing or word processing product like Microsoft Word, and so on. Then another importance, we are saying software is usually cheaper, but in the long run. So at times, you may tell a customer the price of your product, and he or she refuses and continues to do the things manually, but in the long run, the person who bought the product will save. Now, assuming you came up with a bank and you have like 1 million customers, and maybe every day you have like 500 people who visit to deposit, to check for balance, and so on, and you are only using a manual system, people will not line up for a whole day that you are checking their names in the books to write and so on. That means you need very many employees who will do the same task. Yet a single employee can do like 20 tasks that would need 20 employees using a system. And which employees you have to pay for. So in the long run, you find that when you use a software product, you are saving. So that is another importance of software engineering. Let's talk about the software process activities. We have seen that software engineering is a process. And when you talk about any process, there are some activities that combined can all make up that process. That's what I mean by a process. A process is a combination of several activities. So these are the activities now in that process. We have software specification, software development, validation, evolution. Now we are going to talk about each briefly. I've talked about specification already, where the customers and the software engineers meet, discuss, and they define what they want the product to do. And they also put some constraints on how it should operate. Constraints is like you give the guide on the extremes. At least it should do this. So in terms of operation, so that is done between the customer and the software engineer. Then you have the development. This is now where many people think is the big deal, but in actual sense, it is not. You know, if the first processes of software development are done wrong, you will end up with the wrong product. So the person who meets the customer to gather requirements and interacts or makes thorough interviews to exactly know what the customer wants does a very good job. And in software engineering, we normally say that customers don't know what they want. And it is true, I've experienced it. A person will just say, I want a system for the school. And that person will think that for you, the developer, will just come up with a system which does what he has in mind. Now, when you start interacting and explaining, you find out that even the customer himself doesn't know what he wants. Now, as a software engineer, you must do a lot of research. You also look at some other systems that maybe for a school, if you're coming up with a school management system. How are they working? You may even come up with some functionalities that are very important, but when you are interacting with the customer, he didn't mention any of them. And now we find out that without them, then the system is almost useless. So you must add them automatically. So all the activities involved in software engineering process are very, very important. And now after the development, there is what we call software validation. Here you are checking the software to see if it does what the customer wants. You may come up with the software and it has passed several tests. When you put information, it saves, it doesn't bring any error, so you think this is a perfect solution. But now, much as it does that, it may not give the results which are expected. For example, if you come up with an application for calculating, you put 2 plus 3, and it gives you 10. You will not see any error that it is saying there is an error also on. But now the result, you know it is wrong. So that is part of validation. Validation, that's how it's different from testing. Testing, it looks more of the bugs involved and errors, and you see that the software works without any error. But validation is the product doing the right thing, and testing, is it doing it in the right way, without errors, without any problem, doing it in the right way? That is testing. But validation, much as it is doing it in the right way, is it doing it rightly? Is it doing the right thing? So that is software validation. So all that is part of the software process activities. Then you have software evolution. Evolution, we have already talked about it. You develop a product. After 1 month or a year, the customer has something new that he wants you to add. So you have to add it. You should have a way of modifying your product to reflect the changes of the customer. So that is software evolution. So those combined are the activities that make up the software process. Now we have general issues that affect most software. So this means these are not the only issues, but these are the general ones. Almost all products, all software engineers, as they are developing their products, they will face these challenges. One of them, we are saying heterogeneity. Now, in the world that we live in, we have what we call distributed networks. Networks that are in different locations, distributed. And most of the products that we create, the software systems, will work on networks. Now, different networks run different technologies in terms of hardware, the computers, and so on. Now, to have a system that can run on different networks and provide a way of combining the users to access the information from a single source, it's not easy. Now, take an example. You have a hospital that you are developing a system for, and that hospital has taken like 5 years and above. Most, even if it's the same hospital but has several branches in the country, each branch will run on a separate network, on a distributed network. And in most cases, depending on the manager of the branch or the head, they may use different software applications. And if you come up with an application and you want the information from several of them to be accessed from a single source, it is not easy. Because first of all, they may be different products, and they have used it for so long, they have a lot of information. And even the technology in terms of networks is different. So to create a product that can run on distributed networks is very, very difficult. That's why nowadays we are resorting more to web-based applications, because for them, you can host the database and use the browser as long as you have internet anyway and access the product. Then another challenge or another issue is the business and social change. The world we live in quickly changes. Every time new things come up, new technologies come up. So you have that challenge. As you are learning Python programming today, and you think it is the easiest or it is very simple, tomorrow you will hear another language which is even easier. Before you even complete that one, now if you just jump and go to another language, before you finish learning that, they will tell you another language. Even the gadgets, as you buy, maybe, let me use an example of Techno. You buy maybe Techno Camon 15, you think you are now you have the best Techno whatever. Just in a year, they release another one. Before you even exhaust it or you master everything you need, they have come up with another product. So even in the software world, as you are still working on the changes, new changes will come up. Now, to be flexible enough to accommodate all the changes that come up is a challenge. It's not something easy. So that's another issue that we have in software. Then we have security and trust. Now, many people take long to trust software systems. It is not very easy to some people. I remember when mobile money had just come, people were like, how can you convince me that you have given me money when I'm just seeing those digits on my phone? And by then, few people could trust the system, and some people always wanted the cash only. You want to send a person via the mobile money, the person's like, no, for me I want cash, I don't trust those systems. So that is also a challenge. But with the time, it becomes a norm and people get used. I can give another example now. We are using the e-learning platform. And many students that you have been teaching are used to the other way of always having physical classes. So students are like, now how can we understand, how can we learn when we are not even seeing the lecture? So software systems are things that are not easy to trust. And again, security. Excuse me. Dani ndi mu class. Nja kukubira. So you're saying security is another issue. As you are planning of coming up with a good system, you are developing it to see that it works for people, there are other people outside also trying their level best to see that they hack into your system. So that's why some people don't trust software. I've watched several movies for detective, and in most cases, if they people want to ensure that their communication is safe, they will just organize an appointment and meet physically and they talk. Because they know that once you use gadgets which have databases, information can be traced and obtained by another intruder. So security is another issue. Then we have what we call software engineering diversity. Now software has different types and we have several systems that we can develop. There is no single set of software techniques that you can use and be applicable to all types of software systems. So you will always choose the method depending on the type of system that you want to develop, and you will choose the tools that are applicable. So that's what we call diversity in engineering. When you are coming up with a product, you have several ways of doing it. That's diversity. So the process, the software engineering process is diverse. You use diverse tools, diverse methods, and you can never use all of them at once. And you cannot even master all of them, because you can do the same system using different languages and both systems are doing the same job, because we have many options to choose from. Let's talk about the application types. Now here, when you talk about an application, my friend, innocent.
Yes.
What do you think an application is?
Application. Application. Maybe the way I can think about it, it is like the way you can create.
The way you can?
The way you can create apps or different softwares to apply, like applying apps, the way the apps will be working, or the different languages, how you will be using them.
How you be using them? How you apply them? Okay, that's according to innocent.
So I can think.
Joshua, an application. What do we mean in this case? An application.
An application. I think it is synonymous with the software, maybe.
Mm.
Quite in my head, it is synonymous with the software. An application is just like the way we describe the software. It is a set of programs or
Okay.
tools which are accomplishing something.
Thank you. Very good. Now here when you talk about an application, we are not looking at the English meaning
Yes.
of the word application as you were defining that you apply. No. An application, we talked about it in the lecture of Python. We said an application is another word for a program, software. So when you say application types, we are looking at types of applications, not the English usage of the word application to apply, no. But an application is the software types, program types. That's what we mean in this case. Now, software applications are very many. I'm going to talk about some of them. We have the standalone applications. These are applications that run on a local computer, a computer which is not networked, but you have a software anywhere. As long as you install it, you can use it anytime without using any network. For example, when you install your game, you don't need any network to use that application. You install a media player. And we also have even systems that don't work on that are not networked. You only have it on a single computer and you use it there and then. So that is one type of an application. Then you have interactive, transaction-based applications. When you talk about interactive, it means you are able to use the system to interact, to maybe put information, you get the results, and so on. And here, we are basically looking at applications that are used to do transactions. For example, e-commerce applications. Applications whereby you can place an order, you want to buy something, then maybe the user, the different people, those who are using the application, can get the notification, and they will work on your order. Then they will send you the feedback concerning the shipment, where they can get you or where your product has reached, and so on, using the system. So you are interacting. Those are interactive, transaction-based applications. They normally use remote computers to connect to the system via internet. Then we have embedded control systems. What do you think an embedded system is? Or when you hear the word embedded system, what comes into your mind?
Embedded. Okay, I take it is like the way hardware can talk to the instructions, the way software talks to hardware. In my simple understanding is the way the two interact together, hardware and software, the way they come together to interact with each other.
Embed. What do you think?
I think embedded control system, it is concerning with this thing of how you can send a message through like the internet, how you can exchange messages.
How you exchange message?
Via the internet, just written messages.
Embed.
Just to
Now, in English, to embed something means something is like inbuilt inside another one. Put inside, to embed it. Now these systems, when we talk about embedded control systems, as you mentioned, we have hardware devices with software applications embedded or put inside them that will give instructions, and now these systems will work. An example are the automatic irrigation systems. These systems will use microcontrollers and microprocessors, very small ones, and simple instructions. And by use of sensors, they can do automatic irrigation. They can even sense the humidity of the soil and determine the amount of water to pour. So those are embedded systems. You can think of systems that are like smart doors, whereby as you approach the door, it will sense that you are coming and it will open automatically. Then you get out, when you get out, it will close automatically. So such systems that are embedded within the hardware, you don't see the system, you don't interact with it, but it is embedded inside and it will instruct the hardware what to do, the embedded control systems. So that's also another type of application, another type of software applications. Then you have batch processing systems. Now these systems are business systems and designed to process a huge amount of data. Those are batch processing systems. And that's the meaning, okay, it may not be exact, but batch means something in bulk, large. Now these systems, let me give you an example. When you carry out maybe a survey on Facebook, they may ask you questions to ask people to know how Facebook is faring. Maybe it's about the interface and its features, and you answer several questions. Now Facebook has very many users. If like 3 million users, okay, 3 is even limiting it, but maybe 100 million people do the survey. There are no people seated on the computers to read the answers that you are giving and then do the analysis. But they use a system that can analyze that huge amount of data collected and even come up with graphs and recommendations and suggestions. And from that you can know that majority of the people don't agree with this feature. They want us to do it in this way. So systems that do that are batch processing systems. They can process huge amounts of data. So such systems are what we are calling batch processing systems. We have entertainment systems, like the gaming systems and so on, mainly for personal usage. Then systems for modeling and simulation. These are mainly used by scientists and engineers that come up with models of maybe cars, buildings, and so on. Systems like, is it called AutoCAD, that the architects use? And those are modeling and simulation systems. They can create a system that you can even use to learn how to do piloting. If you want to be a pilot, you just sit in the simulation, you learn from there everything before you go to the real aeroplane. So all those systems are under modeling and simulation. That's what you mean by simulation. You are provided with an environment, and as you are in that environment, you work as if you are in the real environment. Okay. Then we also have data collection systems. These are used, as the name indicates, to collect data. Then we have systems of systems. System of systems, that means you have systems, a system which is a combination of other systems in it. In most cases now we have what we call ERP systems, enterprise resource planning systems. You find a single system which can do all the work of an enterprise. Accounting, because initially you could have several different systems and organizations, like Ugema, you have the accounting system for the accounting part. Then you have the student database system. Then you have the examination system. Then you have the e-learning system and so on. Now nowadays, people, the software developers, create what we call ERP systems, enterprise systems, which one system with all those modules. So there are several systems within a single system. So that is system of systems. Then you have software engineering and the web. As I noted, the web nowadays is the way to go. So it is better now to create a software that can run on the web instead of creating a software that is running on a local area network for an organization. It's better to create a web-based application so that irrespective of the branch and its location, the users can access the system and use it via internet. And nowadays, cloud computing is also a better approach, because with cloud computing, you may never run out of space. You create an application that can run on the cloud and people will access it remotely. Now with cloud computing, I'm not going to go into detail, but it has several services. Like it gives you platform as a service. Instead of having maybe Windows operating system from here or the Visual Studio to use or any platform, when you subscribe or you pay, they give you that platform. Resources are there that you can use to do everything online. It also gives you what we call application as a service, ready to use applications. Then we also have software as a service. I won't go into detail, but software engineering now, we have a cloud computing approach booming up, and cloud application developers are on market. So I also urge you that you study cloud computing. Now cloud computing, we don't have it as a course unit anywhere. It is a field that is rising, but cloud application developers are on market. The beauty with it is that we use the same languages as we do here, but now we just learn more techniques. When you are now dealing with the cloud, how do you do it? But if you already have the knowledge of these languages, Python, Java, VB, XML, JavaScript, and others, it's the same thing that you will do, but this time you are doing it on the cloud, not on your PC. Okay, you use your PC, but using other platforms, not the software that is stored on your PC. You read the rest about the web software engineering, but the languages that we use for web, there are very many. That's why you have a course unit called Internet and Web Programming, where you learn languages like PHP, JavaScript, CSS, HTML, and so on. Okay, here we have some key points that we have noted. You read about them, the key points obtained from what we have been discussing. We can continue. This lecture 2 and lecture 1 are still part of one topic, introduction. We are going to continue, but part of this lecture 2, the biggest part, talks about the case studies, giving you example of software applications and their requirements and the diagrams that you read on your own. But I'm going to focus briefly on the ethics of a software engineer. Now, software engineering has what we call ethics. As a software engineer, how are you expected to operate? How should you conduct yourself professionally? That's what you are looking at. So a software engineer, just like any other employee, you have responsibilities that you must fulfill. Now, a software engineer should behave in a good way, just like any other person. Being a software engineer doesn't mean that you go on abusing people. because you can write codes that they can't write. Because the entire organization is using your product, so they are using your brain. Now you start misbehaving. So you should be a well-behaved person. So that is part of the software engineering ethics. Then you have to be an honest person. If there are some challenges that have come up or some problems arising from your product, you should take the responsibility, be honest and accept that maybe there is a mistake and you correct it. So that's being honest. As a software engineer, that is the way you should conduct yourself. Then you should uphold to the law that governs the principles of software engineering. As a software engineer, you should always make sure that your product is in agreement with the laws of the nation. For example, why should you create a program for people who are dealing in illegal business? You know that the business is illegal and you are the engineer. If you've been watching movies, when they are arresting, they also arrest the developers. They don't only arrest the bosses. Every worker, they will arrest you because you are doing something contrary to the law. And in most cases, those mafias, when you finish their product, they will kill you because you have access to many information, a lot of private information. They will even kill you. So as a software engineer, you should gauge and know what kind of product you should come up with or what you should leave alone. And we also have issues of professional responsibility. One is confidentiality, then the other one is competence, and the others that we are going to look at. What do you mean by confidentiality? Confidentiality comes from the word confidential. If the information is confidential, what does that mean?
It shouldn't just be shared
with anyone. So what it contains may be having restricted levels of access. Now, a software developer, since you are going to develop, you are going to put the information and so on, they are likely to give you access to a lot of information that is confidential. But now, to practice confidentiality as a software engineer, you should not be able to just release the information to other people who are not entitled to have access to it, like the competitors of the organization. Because for you, you want money, now you sell to the competitors their secrets so that they outcompete them. That is being unconfidential. Then you have competence. The way you present yourself to the bosses, to the customers, you should present to yourself with a high level of competence. What does that mean? You should accept to do something where you have enough knowledge to do it. Why accept tasks they give you money to end up not fulfilling their needs? You would rather leave it. So competence involves doing something to the expectations of the user. Then we have intellectual property rights. We talked about that indirectly when you discussed the laws. But here, as a software engineer, you should be aware of the laws governing the use of the intellectual property rights. Things like patents, copyrights, and so on. If you're a software engineer, maybe it is an organization patented your product, you are just the developer, they bought it, even the source code, everything, and the copyright is theirs. Much as you developed, they have paid you and you agreed. Why use the same application and now sell it to other clients? They will sue you. So you should be aware of the laws governing the intellectual property rights, things like patents, copyrights, and so on. And you should be very careful, because what the laws that govern maybe the intellectual property rights in Uganda may differ from those in another country like US or like Kenya. So you may go to other countries and you think everything is the same, yet they are different. So you should be aware of and read and have enough knowledge of the intellectual property rights. Then we have computer misuse. This is also an issue of professional responsibility. For example, you have been hired in an organization, you are a software engineer, they find you using the computers for your own gaming. Because you have found out that the organization has powerful computers, you've all along longed to play Need for Speed or FIFA, and now you bring your FIFA, you install it and start using their computers for other purposes. That is misuse. You're a student, you come to our computers and use it to watch YouTube videos for Arsenal, Man U. Still, this professional responsibility is applicable not only in software engineering but in all fields. So still that is computer misuse. And since some people have enough knowledge, you find them intentionally infecting the computer with the virus, then they will inform the boss, you know what, your computer has viruses, but I can help if you only give me maybe 50K. You are the person who put the virus, now you want to remove it. So that is still misconduct, misuse of the resources of the computer. So as a software engineer, you should do away with such conducts. Now we have SCM and IEEE Code of Ethics. SCM and IEEE are organizations in engineering, in computing, that are international, and they come up with standards, code of conduct for people in such fields. So these two, they come up with several instructions and principles that can guide software engineers, supervisors, policymakers, educators, students, trainees of professions in software engineering, in engineering of other fields, in computing generally. So you can also read about their documentation and get to know more about how a software engineer is expected to conduct him or herself. Here in the slides we have examples of those conducts. You read about them, and the rest are just case studies. You read about them, case studies of software engineering projects. Now, let me welcome any question or comment according to what we have discussed.
So when it comes to the code of conduct, to what extent is that part examinable? Like, I'm just saying, should we just know maybe the organizations that come up with these rules? Maybe should we know some of the rules, some of the code of conduct? To what part is it examinable? Or we should like extensively know everything?
Now, because you're a software engineer, you are an ICT person, they will give you the code of conduct for software engineers. But not everything they give may be applicable anywhere. It depends on the laws still of that organization. Or not the organization, the laws of the country or the nation. So depending, but they give general ideas and views of how you could conduct yourself as a software engineer. But most of the, of course, people involved, they normally based on the US laws. When you are reading those, for example, when you're installing software and reading the end user license agreements from developers of other countries like US, in most cases, I've tried to read them, but you find very many regulations given, they base on the US laws. Now, as you consult these companies and read their code of conduct, they still quote where if the regulation is taken from a certain company or a certain country and it's applicable there, they will quote that. So for you, you should also know, for example, from the Ministry of ICT, how they expect the ICT people conduct themselves in Uganda. You can read and get to know what is applicable in Uganda or in any country before you fall into trouble. And again, for any organization still as a software engineer, or if you are the ICT admin or whatever, you also create your own ICT policy to guide users on how they are expected to conduct themselves when it comes to the ICT and how to use maybe the ICT gadgets. And you also still do that basing on the laws of the nation, then you also add what you think is more applicable to your organization.
I want to go to you on the applications. I want to go to you on the applications. You can add on applications.
Application types.
Don't say application of, because you've not said that, but the application types.
And what application?
Now here, in software in general, software is a set of instructions that that tell the computer what to do. That is software. Software mainly has two types. We have what we call application software and what we call the system software. Now the application software is a type of software that is used to accomplish specific user tasks. You, the user, for example, if you want to type a letter, you look for an application software to use, like Microsoft Word. You want to play music, you look for an application for the software to play music, like Windows Media Player, like VLC. So those are application software. As long as you have a specific task you want to do, you want to accomplish, you look for a suitable application. So the word application in this sense means that program that we use to accomplish specific tasks. But again, the word application in English has another meaning which we are not using in this sense. When you say application types, we are looking at the types of applications, types of the application software, all types of programs. So that's what we mean by application in this sense.
What about system software?
Okay, that I gave you the two. I was only looking at the other side because that any computing student, even before you come to the university, that is the knowledge that you are expected to know. Application software, system software, because you know that system software is the software that manages and controls the application software. It works as the intermediary between the application software and the hardware of the computer. And the best example we can give is the operating system like Windows, Linux, and so on. But that was by the way which I didn't want to go into. Okay, thank you. Any other question before we wind up? There isn't. So as I told you, I've been recording this session. So those who are online that have not been able to make it, they will find the discussion there. Okay, thank you.